So let's talk about linear equations. So with a linear equation, you are relating two variables. We're going to have x and y. And the idea is, and we'll see how this comes together in a later example, is that when you get all of the possible solutions for this equation right here, when you have all of them graphed together, they make a line. So let's say we just want to know what one solution is for this equation. So when we've talked about solving equations before, we've just had one variable, like maybe a scenario would have been 10 equals 4x minus 7, and if I told you to solve, then you would just go through our steps and you would end up with x equals and some number. Now, what's a little different here is that instead of having a number over there, we have a second variable. So with that, if I go through the steps for solving for x here, I'm going to end up with some formula involving y, which doesn't particularly help us in terms of a solution. So what we do in this scenario where we have two variables and I want to know what a solution is, what we do is we just pick a value for x. Pick a value for x. And it can be absolutely anything. Any number that you want to use, plug it in. So I'm gonna let x equal, how about 2? Not very exciting, but if I let x equal 2, then what I would do is I've chosen a number for x and I'm gonna plug it in. So that means I would go y equals 4, and then where I had x before, I'm gonna put parentheses 2 minus 7, which is 8 minus 7, which means y is equal to 1. So at the end of this, what I have is a relationship that if x is equal to 2, then y is equal to 1. And having this x and y pairing that works for this equation, that's a coordinate. So this is a possible solution, and what I could do is write this in coordinate form as the coordinate to 1 is a possible solution. So the idea being, I just chose a value for x, plugged it into our equation that we're given, and solved for y. So I could do the same thing, and let's say I let x equal, let's do a negative number. How about negative 10? Then what I would do is I would go y equals 4, and then remember those parentheses, especially with negative numbers. So times negative 10 minus 7. So multiplying 4 times negative 10 is negative 40, and then minus 7. And y equals negative 40 minus 7 will be a negative 47. So now I have this pairing, if x is equal to negative 10, then y is going to be negative 47. So we have this solution at negative 10, negative 47 as a coordinate with x and y is a possible solution. Now, as you can imagine, I could do this all day. I could just keep choosing numbers for x. I could let x equal 0, let x equal 152, and what it would entail is just plugging in these different values here and then using this relationship, it'll give you this y coordinate that goes with it. So what we would end up with are all these different coordinates. And like I was saying, I could literally spend the rest of my life doing this because I can plug in absolutely anything for x. I could get into decimals, I could let x equal pi, I could do all sorts of things. And with that, we end up with a bunch of coordinates, infinitely many coordinates, in fact. And what that does is when we would start to make a graph, which is going to be our next step, we would get these coordinates, and maybe it would look something like this, where you'd get all of these coordinates, and if you plot absolutely all of them, it makes a line. Like even more accurately, where I have these little spaces, that's not necessarily true because there's infinitely many of them. They just stack right next to each other. Sorry, this isn't a very straight line, but to the point that it would make this line right here. So with that, if we have an equation that looks like this, where we have x and y, something that makes it linear is that there is technically an exponent of 1 on x. If we saw a 2 right there, that changes the shape of the graph, or really any number as an exponent there changes the shape of our graph. So for linear, we have this form. In fact, something we're going to talk about in the following videos is this form y equals mx plus b, where m is a number, b is a number. That's the form we have here, like m is 4, b is -7. This form right here is used for linear equations. I'll talk about that a lot more in a later video, but just to give you an idea, or if you've seen that form before, that's what we're looking at here. Okay, so with this, when we have a linear equation, we can get infinitely many solutions which come through as coordinates on a graph, and when you have all of the coordinates, they make a line. So let's move on to this next example. What we're going to do is we have a table set up here. We're going to complete the table by finding 5 solutions for this y equals -2x plus 1. Now, looking at this table here, we're kind of stuck because there's no information. So what we need to do is kind of like what we did up here, and we need to choose values for x. Now in setting up a table, what I typically do is I think about that I want to see values for x that are both negative and positive. So maybe in the middle there, I'll throw in 0, and then maybe I'll go like -1 and +1 and -2 and +2. That'll kind of show me what's going on around the y-axis in a way, because we're letting x equal 0. So having 0 in there can be a good idea. And then I just go negative, positive. You could do -2, -4, +2, +4. You could go by 5s. Really, it's up to you. Because in the end, we should be getting the same graph out in the end. It's just that you might be grabbing different coordinates along the line than I would be graphing, but in the end, it's all on the same line. So once we set up x, and again, I just chose those values, you can choose different values. This setup just tends to kind of help in terms of graphing. Now to find y, what we're going to do is plug into this -2x plus 1. We're using this formula up here. So what I would do is look at each of these, taking -2 times x plus 1, and what I'm going to do is, to substitute in there, I'm going to use each of these x values. So let's solve. If x is equal to -2, then y is equal to -2 times that x value of -2 plus 1, which is a +4 plus 1, which is 5. So what this tells me, if x is -2, then y is +5. And what I can do is take that +5 and plug it in right there. And that gives us this coordinate, -2, 5. So then let's look if x is -1. We're going to do y equals -2 times x plus 1, where x is -1. -2 times -1 is +2. 2 plus 1 is 3. So if x is -1, y is +3. So that means we have this coordinate, -1, 3. All right, if x is equal to 0, then we're going to have y equals -2 times x plus 1, where x is 0. -2 times 0 is 0. Plus that 1 is a +1. So we're going to have this coordinate 0, 1. If x is +1, then we're going to have y equals -2 times x plus 1, where x is +1. So this will be a -2 plus 1, which is a -1. So we'll have this coordinate 1, -1. And our last one here, if x is +2, then y is equal to -2 times x plus 1, where x is +2, which means we have a -4 plus 1, which is -3. So with this, you can use a calculator to help out too. You're really just plugging in and switching the value for x and solving. But it comes down to this where you're just taking this format that's given to you for what y is equal to and plugging in different values for x. So with this, we end up with all of these solutions that we can now graph. So we're seeing positive and negative x values, we're seeing positive and negative y values. So with that, I'm just going to have the origin right in the middle of the graph. Let's see, we have x and y, so we need to label our axes. I need to set a scale, which these values are pretty small, so I'm just going to use a scale of 1. So for coordinates, we have -2, +5. So we have a coordinate up there. We have -1, +3, which is right there. We have 0, 1, which is right there. 1, -1, right there. And 2, -3, right there. Now, what you can see is that these are lining up exactly as they should be. Knowing that this is a linear equation right here, that means any solutions that we graph should all line up, meaning I could put a ruler down on this paper and it goes through all of the lines. Let's say for some reason you're getting solutions out and one of these was like out there. If I know that this is a linear equation and these are all lining up except for that one, that's going to tell me something went wrong there. I did math wrong there. And so what I would have to do is go back and check my work because they should all be lining up. In the previous videos, we just had random points to plot. They weren't coming from a formula. However, in this case, we had this equation to work with, so they should all line up in terms of that behavior, which should be linear. So what I can do is to graph all possible solutions, we would connect those dots with a straight line. Now I could see, like, if I plugged in -1.5, then I would be landing up there at +4. So I could see as other possible solutions that we didn't even solve for coming through with this linear equation. Like if I had gone all the way to +3, we would have been getting -5 out. So all of these coordinates are possible solutions to the equation here. We just need a few to get us started with graphing a line. Typically for graphing a line, the minimum is 3 coordinates. Technically 2 coordinates is the minimum because really you just need 2 dots in order to line up your ruler and draw a line. However, it's always recommended to do a 3rd one to make sure something didn't get messed up. Again, for that case where if you have one of your values off to the side, that can be a way of checking your work to make sure that it was graphed correctly.